Hello everyone, welcome back to Shibi's chemistry classes. Today we have to see the action of ammonium hydroxide reagent on certain salt solution. So in our previous video we have discussed about action of sodium hydroxide on certain salt solution, and we have seen what type of precipitation occurred and observed the color of the precipitate. On that basis we could identify what salt is present in the given sample. So we are dealing with qualitative analysis in which we have studied sodium hydroxide reagent, and today we have to see ammonium hydroxide as reagent and its action on certain salt solution. So let's start one by one. We know about certain colored and colorless uh, metal ions, and only few metal ions are colored, and rest most of them are colorless, whether it is cation or anion. So we have seen colorless and colored ions. So now we will see the action of NH4OH. So first we'll take salt solution, then we'll add NH4OH, and we'll observe the precipitate. What precipitate? Metal hydroxide. It will be the same as the previous one. Metal hydroxide precipitate, and precipitate will show by this downward arrow, and a salt which is soluble in the solution, and then we'll observe the color and what happens when this reagent is added in excess. In the previous case, we have done the same thing. First, we added the reagent drop by drop, and after precipitation, we added the reagent in excess. So, in some cases, the precipitate became soluble, and in some cases, it remained insoluble. So, similar procedure we have to repeat here again. So, first, we will take calcium salt. So, first salt that we are going to take is calcium salt. And with calcium salt, no precipitation take place. No precipitate is formed even if it is added in excess. What is the reason behind this? See, we know that this ammonium hydroxide is an alkali. Alkali means a water soluble base. We are talking about NH4OH. This NH4OH is a water-soluble base, so when it is dissolved in water, it ionizes to produce ammonium ion and hydroxide ion. So since it is a weak alkali, we know that it is a weak alkali. What are the strong one? NaOH and KOH are the strong alkalis. These strong alkalis means when ionized in water, they produce high concentration of this hydroxide ion. And bases give hydroxide ion, and acids give hydronium ion. So what happens in case of ammonium hydroxide? It is a weak alkali and it ionizes, producing very less amount of hydroxide ion, and it is so less that it is not sufficient to cause the precipitation here. When this salt is reacted with NH4OH, the concentration of hydroxide ion is not sufficient to cause the precipitation. So that is why with calcium salt no precipitation take place. Next we will take iron. You have to give reason also. And if you get the question why no precipitation take place with when ammonium hydroxide is added to calcium salt even in excess. So you have to cite the reason also. So next is iron, and we know that iron exists in two valence state. Iron symbol is Fe, and two state ferrous and ferric. So first we will take this one. So the example is salt is ferrous sulfate, iron is in +2 valency state. Ferrous sulfate, and then we'll add NH4OH. So first we'll get a precipitate of metal hydroxide. This is metal and this is hydroxide. So FeOH twice and one salt that will remain soluble in the solution. So what salt it will be? It will be NH4 twice SO4, and you have to observe the color. So just try to recall what is the color of this ferrous ion. So this ferrous ion is green in color and sulfate is colorless. So the resultant solution will be green in color. This ammonium hydroxide is also colorless. So what precipitate it will produce? It will produce a dirty green precipitate. Dirty green precipitate and a colorless ammonium sulfate. And what happens if ammonium hydroxide is added in excess? The precipitate will remain insoluble. It was same in the previous case when sodium hydroxide was added to this precipitate, it remained insoluble. We'll take one more example of ferrous salt. No, we'll take ferric salt now, ferric chloride. Add ammonium hydroxide, you will get FeOH thrice as precipitate and now try to recall the color of this ferric ion. What is the color of ferric ion? Yellow. Yellowish brown. Its color is somewhat yellowish brown. So when you get this precipitate, it could be of reddish brown color. And addition of excess of NH4OH would not be able to dissolve this precipitate and it will remain insoluble in the solution. One more example we will take. Color of the precipitate would be the same, reddish brown. So first we have seen the action of ammonium hydroxide on calcium salt. So no precipitation occurred. Next we have seen iron in both the state, +2 and +3. +2 is called ferrous and +3 is called ferric. In ferrous we have taken ferrous sulfate, added ammonium hydroxide, we got ferrous hydroxide precipitate, dirty green color precipitate which remained insoluble in excess of ammonium hydroxide. Then we took ferric chloride, got the same precipitate but this time it could be of reddish brown color because ferric salt is yellowish brown in color. So that is why the precipitate that we got over here is reddish brown in color and it will remain insoluble in excess of ammonium hydroxide. And one more example of ferric sulfate we have taken here. Now the next salt we have to study is copper salt. So learn this in sequence. It would help you to memorize it. First we took calcium, then took iron. Now we'll take the third one, copper. Its symbol is Cu and its valency is +2. That means it could donate 2 electrons to complete the octet and become stable. So this is called copper to iron. Now we'll take one example, copper sulfate. Both are having 2 valency, so that is why formula would become CuSO4. Then we have to add NH4OH and observe the precipitation. It could be of a metal hydroxide, so metal is copper in this case, hydroxide is this CuOH twice plus this salt. What salt? NH4 valency could be twice SO4. And now we have to observe the color. So this we know that this cupric iron is a blue in color. This copper iron is blue in color, and so it would give pale blue precipitate. Pale blue precipitate. But this time, when excess of ammonium hydroxide is added to the solution, the precipitate gets dissolved. The precipitate gets dissolved and forms deep blue solution. That means this precipitate is soluble when excess of ammonium hydroxide is added to it. Now we have to see the reaction. Take this copper hydroxide plus ammonium sulfate, then add NH4OH in excess. This time is added in excess. Now it could form a complex that is called tetraamine copper 2 sulfate. Tetraamine. Tetra 4 times NH3 amino group, copper this is tetraamine. This is a complex compound, tetraamine copper 2. Copper is in +2 valency state, so that is why +2 is written over here, and water. We have to balance this equation. NH4 copper is 1, sulfate is 1, OH is 2, NH4 is 2, so we'll put 2 over here. Next equation also 2, make it 2. 4 3 is 12, 13, 14, and hydrogen is 14. 8, 9, 10, 11, 12, 20. 4 2 is 8, 4 2 is 12, so 20. Both sides balanced. So this is the important reaction, because here the action of ammonium hydroxide in excess resulted in a soluble solution of tetraamine copper 2 sulfate. Means the pale blue color precipitate dissolved and gave a deep blue colored solution. So this is the characteristic property of Cu2 plus ion and is used for the detection of the presence of this ion in qualitative analysis. Means the color that you get here when NH4OH is added in excess, the deep blue colored solution. So that is the characteristic of this Cu2 plus ion. Means if you are getting this type of solution while performing this qualitative analysis, that means you could immediately confirm the presence of Cu2 plus ion in the given salt. Next we'll take zinc salt. So in the previous one, when we saw the action of sodium hydroxide, so there we had two ions that remained soluble in with excess of NaOH, zinc and lead. In excess, it produces sodium zincate and so when NaOH is added in excess, we got sodium zincate, and when with lead, we got sodium plumbite. So here with NH4OH, we have seen that Cu2 plus ion got soluble. Now next is zinc salt. Symbol zinc. So we'll take ZnSO4. Then we'll add NH4OH and make a precipitate of metal hydroxide and a salt. Now what could be the color of this zinc? So it is colorless. So we will get white gelatinous precipitate. Gelatinous precipitate. Gelatinous means a shining sort of precipitate. Sometimes we write dirty. So dirty precipitate, they don't have shine. So gelatinous means they are having shining appearance. And it gets soluble with excess of NH4OH. So after getting this precipitate, when NH4OH is added in excess, precipitate dissolve. So it would also form a complex compound. NH4OH could be added in excess. So we will get tetraamine zinc 2 sulfate. In the previous one we got tetraamine copper 2 sulfate. Now here we will get tetraamine. Tetra means 4 amine zinc 2 sulfate. And it would be colorless. So this tetraamine zinc 2 sulfate would be colorless. Next we will take lead. This is fourth one, and this is fifth. Lead symbol is Pb plus 2 valency state. We will take lead nitrate, added NH4OH, lead hydroxide, white precipitate, and what salt? Ammonium nitrate. NH4 NO3, and the precipitate is insoluble with excess of NH4OH. So when added in excess, you will get the color would change to chalky white. This chalky white you would get when NH4OH is added in excess. Initially, when it is added dropwise, you get white precipitate, and when you add NH4OH in excess, that precipitate will remain as such, but it is converted into chalky white precipitate. Means the appearance will change. Now we would see the action of alkali on certain metals. So by now we have seen the action of alkali on salt. Now we will be seeing the action of alkali NaOH on certain metals like zinc, aluminium. There also it will produce salt. Metal plus alkali. Metal plus alkali. So you will get salt plus hydrogen gas. Suppose you take zinc, alkali is NaOH. This is sodium zincate and hydrogen gas. These are the soluble salts, no? So when you react, this is hot and concentrated alkali. When it is allowed to react with any metal, it will form its corresponding soluble salt along with the liberation of hydrogen gas. This is sodium plumbite. This is sodium zincate. Potassium zincate, sodium plumbite. Now next topic is action of alkalis on metal oxide. See, we know that metal oxides are basic in nature because when they dissolve in water, they produce a base. Metal oxides. Try to recall what are metal oxide. The next topic is action of alkali on metal oxides. So what are metal oxides? Metal when combined with oxygen, they are metal oxides. So these metal oxides are of basic nature because when they are dissolved in water, they produce a base, an alkali or a base. So these metal oxides and hydroxides, and we are talking about these metal oxides and hydroxides that are basic in nature. They neutralize acid producing salt and water. Means these metal oxides, they only neutralize acids. So when they are made to react with the acid, salt and water is produced. So this is a neutralization reaction. And this is a base. This metal oxide, it is of basic nature. So when it is made to react with an acid, it produces salt and water. But there are some metal oxide that react with both acid and bases. Some metal oxide, they only react with acid. They don't react with base, like this sodium oxide. It only react with acid and it would not react with a base. But there are certain metal oxide that react with both acid and base. So that type of metal oxide, they are called amphoteric. They are called amphoteric oxide. means metal oxide that could react both with acid and bases. So some examples of amphoteric oxide: zinc oxide, aluminium oxide, lead oxide. So these three, they are of amphoteric nature, means they react with both a base and an acid. Similarly this, and produce salt and water. So we have seen the action of alkalis on metals. Earlier we have seen the action of alkali NaOH and NH4OH on salt solution. Then action of these alkali on metals, and then action of alkali on metal oxide. Metal oxides are basic in nature, and most of the metal oxides, they only react with acid and produce salt and water. But these three, they are of amphoteric nature, means they react with both acid and base and form salt and water. Now we'll see some questions which is given in your textbook. So the first question is, write the probable color of the following salt. You have to tell the color of the salt. First is color. What salt? Ferrous, ammonium, cupric, calcium, aluminium. See, we have studied all these salts and we have noted down the color also. Ferrous means Fe plus 2, because iron, we have studied iron in two valency state. One is Fe plus 2 and one is Fe plus 3. So when we are saying ferrous, that means we are talking about Fe plus 2 and it is light green in color. Ammonium NH4 plus, you have to memorize this formula. It is very important because without formula you won't be able to write the chemical equations. So formula is very important. Learn the formula of the common metal and non-metals as well as their valencies, and then only you will just write the proper valency or write the formula. If you don't know the valency, your formula will not be correct. Cupric, Cu plus 2, and calcium Ca plus 2, aluminium Al plus 3. So we have studied that the representative element group 1, 2 and from group 13 to 17, they are mostly colorless. We have studied this in our first lecture that group 1, 2 and elements from group 13 to 17 are mostly colorless, and the elements that are present in between them, means the representative transition elements, they mostly form color compound. So this calcium is colorless. Calcium is colorless. Cupric blue. Ammonium colorless. Aluminium colorless. Write a balanced equation. For the action of hot concentrated alkali on aluminium. You have to write the balanced equation for the action of alkali on aluminium, means action of alkali on metal. So aluminium plus NaOH, water is needed. So you will get sodium metal aluminate. Sodium this reaction you have to learn. Next question is what happens when ammonia solution is added first dropwise and then in excess to the following solution. Now we have to see the action of ammonia hydroxide. Not ammonia, it is written incorrect over here. We have to see the action of ammonium hydroxide to this solution, copper sulfate. Just now we studied this. Try to do it by yourself. This is blue. We will get copper hydroxide, blue, and a salt. So this is when the ammonium hydroxide is added drop wise, means in little quantity. But what happened when it is added in excess? So this will get dissolved and give a dark blue colored solution with the formation of a complex that is called tetraamine copper 2 complex. Just try complete this equation. Just now we have done it, and I have told at that time only that this reaction is very important because it is the characteristic of this cupric ion only. It gives a deep blue color solution when ammonium hydroxide is added in excess. Similarly, you have to show the action of ammonium hydroxide on zinc sulfate and ferric chloride. So see, mostly you get these reactions only in this chapter. Nothing else. These reactions are only important, so you have to practice it by writing some 4-5 times. Then you'll be able to solve the questions. But the most important thing that you have to do is first learn the periodic table, make yourself familiar with the symbols, its valency, and some of the very commonly found metals which we are frequently seeing these examples again and again. We are just seeing this, so you learn those examples very nicely. So in the next video we'll start another chapter. Till then, have a nice day.